In this video, we're going to learn a rule that we use when we're trying to define the derivative of a product of two functions. Now, in a previous lesson, we saw that if we have a sum of two functions, say for instance y is equal to 4x squared plus 5x, we saw earlier that we can find the derivative of each function separately and just add the derivatives together. So for this example, my derivative would be the derivative of 4x squared, which is 8x, plus the derivative of 5x, which is 5. And whenever we have a sum of functions, this works. But when we have a product of functions, we get a little bit of a different result. Let's consider y equal to x cubed times x to the fourth. Now this is simple enough. I can just multiply these two functions together, and I get x to the seventh. And then if I take the derivative of x to the seventh, that derivative would be 7x squared. But let's rework this problem, taking the derivative of each function first and then multiplying the derivatives together. So x cubed times x to the fourth. If I take the derivative of each one separately, the derivative of x cubed is 3x squared times the derivative of x to the fourth, which would be 4x cubed. And if I multiply those two things together, I get 12x to the fifth, which is not the same as 7x to the sixth. And so we can see here that just finding the derivative of each function separately and then multiplying, it doesn't give us the correct result. The derivative is not equal to 12x to the fifth. The correct derivative is 7x to the sixth. So let's look at the rule that we can apply in these situations. The rule is called the product rule. We use it whenever we're trying to find the derivative of a product of functions. And the rule looks like this. The derivative of two functions f times g is equal to f prime times g plus g prime times f. Now I'm going to go back to my example. Y is equal to x, oh no, it wasn't squared, it was x cubed times x to the fourth. And this time I'm going to use the product rule. Now we already know the derivative is 7x to the sixth, but let's see what happens with the product rule. X cubed times x to the fourth, the x cubed, that's going to be my f, x to the fourth is my g, and so my derivative is going to be equal to f prime, which would be the derivative of f, or 3x squared, times g, which is x to the fourth, plus g prime, the derivative of g, which would be 4x cubed, times f, which is x cubed. So now I'm going to multiply these terms together. 3x squared times x to the fourth would be 3x to the sixth, plus 4x cubed times x cubed would be 4x to the sixth. And if I add those together, I get 7x to the sixth, which is what we already knew the derivative should be. Let's look at another example. This time I'm going to multiply x squared minus 3x plus 1 times 4x minus 5. Alright, so this is a product. Y equals over here. So we're going to use our derivative rule. This first function, x squared minus 3x plus 1, that's going to be our f. The second function is going to be our g. And I'm going to rewrite the rule here just so we can reference it. Derivative of f times g is equal to f prime g plus g prime f. So let's work this derivative. We're going to start off with f prime, which is the derivative of f, 2x minus 3, times the function g, which is 4x minus 5, plus g prime, the derivative of g, which is 4, times the function f, x squared minus 3x plus 1. And so now we need to multiply this out and combine like terms. 2x times 4x would be 8x squared. 2x times minus 5 is minus 10x. Then negative 3 times 4x is negative 12x, and negative 3 times negative 5 plus 15. And now I'm going to distribute the 4, so plus 4 times x squared, and then minus 4 times 3x is 12x, and 4 times 1 is 4. And last step here, combine like terms. Let's see, what have I got? 12x squared, and then minus 10x minus 12x would be minus 22x, minus 12 would be minus 34x, and 15 plus 4 is 19. So our derivative, 12x squared minus 34x plus 19. I'm going to do one more example for you involving an exponential. Y is equal to 3x to the fourth minus x squared times e to the x. So again, we're going to apply the product rule. 3x to the fourth minus x squared, that would be my f. E to the x is my g. The product rule, again, derivative of f times g is equal to f prime g plus g prime f. So let's find our derivative. I'm going to start with f prime, the derivative of f, and that would be 12x to the third minus 2x times g, which is e to the x, plus g prime, the derivative of g, and the derivative of e to the x, remember, is still e to the x. It's the one function whose derivative is itself, times f, 3x to the fourth minus x squared. So at this point, whenever you have a product involving an exponential, notice I've got two terms here. This is all a term being added to this term, and they both have an e to the x. And that's what happens when we do product rule involving an exponential, because the derivative of the exponential function is itself. And so you're going to end up with an exponential function in both terms. So I'm going to factor that out to the front. And in the first term, I have left 12x cubed minus 2x. And in the second term, plus 3x to the fourth minus x squared. And I don't have any like terms there to combine, and so that's my final answer.